All right, so welcome back, everybody. Now it's lightning talk time. We have 2 lightning talks in a row, so we need to hurry up a little bit. First of the speakers, he's a lecturer at the University of Applied Sciences, Technikum Wien. He's originally from Vienna. He's the co-founder and the chief technologist at Square. David Leitner, talking about platform engineering beyond the buzzwords.
Hey, thanks a lot, Daniel, for the introduction. I will make it very short because I just have 15 minutes left, and I think it's kind of elusive to talk beyond the buzzword in 15 minutes, so I would rather call it that I probably talk about platform engineering for the rest of us. And I just did a few last-minute changes, as I usually do, and I decided to split it up in 3 things, to split up why platform engineering in the first place, because I think as often in our industry, we have the problem that we do a lot of platform engineering these days, but we are not 100% certain anymore why we actually started all this, right? Then I would like to go a little bit into platform engineering topologies and anti-patterns, and then I would like to talk about how we can scale platform engineering, because basically that's what platform engineering is for, right? To scale our organization in terms of engineering. It's a little bit of a spoiler already. And I have for all those 3 things 5 minutes, so let's get this done. So first things first, my name is David Leitner. I usually call myself a coding architect. I work for a company called Square Solutions. You can find the rest afterwards, so to say. I'm here for the rest of the day, so I can also answer all the questions afterwards. So who of you is actually doing cloud architecture? Who is consider himself as a solution architect, cloud architect, software architect, whatever? Okay, so you work in the wonderful world where I often also work, and you work basically with verticals and horizontals, right? That's what we usually do in architecture. We decide on verticals or horizontals. And back in the days, hoppala. Okay, that just popped up something on my screen. Back in the days, we basically structured our solutions mainly on horizontals, right? And you basically already see in the picture that there is no right or wrong thing. Yeah, it's not right or wrong to do it based on horizontals or to do it based on verticals, because basically it makes sense to, you know, kind of bring all things together with the same color, or to bring all things together with the same shape, right? The problem is just if now all the things with the same color change and you structure them by the same shape, then it's of course problematic. But in the other way, if you go in this direction and all the things with the same color change, or with the same shape change, then you have a problem in that direction, right? But what is obviously seeing is that we basically moved in our industry from, you know, more like horizontalized teams with persistence, domain, front end, whatever it is needed, right? How we usually structure our organizations, how we usually structure our teams, in a different direction, right? And there's a second change, that we basically usually had these things in a single deployment unit, which made them actually easy to govern, right? So if you had, you know, multiple teams working on the same deployment unit, working on a classical monolithical application, you were able to define the framework they're using, you were able to define some core patterns, you were able to define some guidance and governance that this actually even works, and these horizontal layers can work with each other, right? And the big shift in our industry, I think in the last couple of decades, or in the last decade, was basically to shift to verticalization, right? That we started to say, okay, we basically don't want to slice our teams based on technical means, but we want to slice them based on customer journeys, right? So we said we have a product catalog team which takes care of that we can kind of sell products, right? We take care of a payments team, which then basically takes care of the payment. We have a delivery team, and we have a warehouse team, and whatever we need, right? And what we did in that cause is basically that we introduced service-based architectures like microservices. And we said, okay, you know, we basically want to give those teams also autonomy in terms of independent deployment units, because high autonomy usually means high pace, right? That was the base assumption of the movement in our industry for the last couple of years, I would say, right? It turns out that this is partially true, right? Because strict governance usually means that you as a developer, that you as an engineer can slowly move forward because you're restricted by all the things within your organization, right? So we shifted to this idea of DevOps where we say, okay, you own it and you build it and you run it, right? So you can build it the way you want to build it, but you basically also need to run it the way you want to run it, right? So who is working in a 24/7 co-location team? So who is basically taking care of you build it, you run it? Who really does this here in this audience? Who is working in such a team? Okay, and that's usually the assumption, right, in Central Europe, that we talk a lot about you build it, you run it, but usually we basically don't have it in most organizations, right? And this, of course, comes to the downside that if you do, you build it, you run it, but you basically just build it and somebody else needs to run it, then autonomy basically gets a little bit of a pain, right? Because it gives you this, unfortunately, speed paradoxon, right? Where suddenly things get very slow because you build everything twice, right? Somebody else needs to operate it for you, and this somebody else needs to operate different technology stacks from different teams, and you basically stop sharing things too heavily because you want to have mostly autonomous teams, right? And this leads us to the speed paradox and the standardization paradox, where people then figure out, well, a few standards would actually help us to get faster again, right? And as always, the middle ground is somewhere the best, right? And this middle ground is usually what we tend to call the golden path, right? And I'm not the only one who observed this, obviously, right? As I said, I think that's the driving factor in our industry these days when we want to scale organizations to deliver software faster. And I think two people really got this very well on point, and these are the two guys from Team Topologies, Matthew Skelton and Manuel Pace, who basically define 4 different teams, and one of them is the platform team. That's why I'm talking about this all, right? Because they say basically we want to have these verticalized organizations. We want to have those teams which have end-to-end responsibility and which can work autonomous, right? Otherwise, people cannot take the end-to-end responsibility if they are not autonomous in a way that they can decide on their own, right? And what we realized, and I think we realized this again and again and again, right, that these independent end-to-end value streams make a lot of sense, because always if you split this up, right, always if you split, for example, the ordering into multiple smaller streams, right, which need to talk with each other, it's usually painful, because this interaction between those teams usually takes a lot out of the pace which you want to have in your organization, right? But on the other hand, we also realized that if we want to have these full end-to-end customer journeys, right, like in this case, you can order a product, right, or you can buy a product, right? These are huge domains, right? And we want to have them as good as end-to-end in teams, but this usually leads to this high cognitive load in the teams, right? Where they say, we cannot handle this whole end-to-end journey, right? Starting from front-end applications, going over back-end services and so on and so forth, and a lot of complexity when it comes to the business domain itself, right? And this cognitive load is then basically teamed by 3 other teams usually in organizations, right? What you usually have is you have those enabling teams. You can think of them like in-house consultants. They go to teams, SREs, for example. SRE, for example, are enabling teams, right? They help those teams to speed up the stuff, to kind of get familiar with the technology, whatever is needed that they can faster deliver business value, right? Then we usually have these complex subsystem teams which take care of a complex domain, right? I don't know, fraud detection, ledger systems in banks. Things that you want to carve out of these verticalized teams because they would basically just bloat them too much, right? And what I'm talking about is basically that they also mention the term of platform teams, right? Where they say that these platform teams, again, also have the solution or have the mean to carve out cognitive load of these verticalized teams, right? That's why we need all those additional teams, right? If they don't make this job to kind of reduce the amount of cognitive load for your stream-aligned teams, then you probably don't need those teams, right? That's their only reason for existence, right? And these platforms can be a lot now, right? And we will talk about today about internal developer platforms, but it's very important that it doesn't have to be an internal developer platform, right? It can also be a design system. It can be an IoT hub. It can, whatever it needs, right, to get those teams faster and to provide value for them. And I will talk about internal developer platforms in the context of these platform teams, because obviously they are a platform team which we can utilize a lot to scale our organizations in terms of delivering software. And I refer to them usually as internal developer platforms, right, which is a different term. And I like usually the definition of Ivan Boccia, who says a platform is a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product, right? And there are a few important things in this sentence. Probably the most important one is internal product. We will talk about this later. And what they basically do is that the autonomous teams can then make use of this platform to deliver products and features at a higher pace with reduced coordination, right? again, the whole idea is to reduce the cognitive load of the teams which need to deliver business value, right? And how this usually looks is that we now started this, right? We said, oh, that sounds like a good idea. Let's introduce platform teams again, right? And what they in the beginning usually do is they operate the Kubernetes cluster, right? So there's another team which basically builds a microservice architecture, whatever, right? And they obviously need some container orchestration tool. And in most cases, it's obviously Kubernetes these days, right? And then there's a second team, right? Which is building up on this platform. And this second team maybe already needs much more, right? They say, okay, it's nice that you give us a Kubernetes, but we basically also need monitoring, logging, alerting, all those things, right? And the more teams we get, basically, the more demands we have, right? The third team maybe comes and, hey, we do event-driven architectures, please give us a Kafka or any other event streaming platform, right? And last but not least, we end up in this huge platform, right? Where we put all these fancy tools from the CNCF landscape in and say, hey, this is our platform team. And basically what we wanted to avoid in the first place, that we kind of reduce the cognitive load, is that we basically just shifted the cognitive load, and that we just basically created a new bottleneck in our organization, right? And beside this, that this will definitely become a bottleneck, right? And teams will start to work around this platform and will probably not benefit from it anymore. These monolithical platforms, I tend to call them, usually also have the downside that they are hard to kind of, float with time. And what I mean by this is that usually you build your platform not from scratch. You build it on something, right? There's a base platform, there's a hyperscaler, there's AWS, there's GKS, there's whatever you need, right? Where you build your abstraction on top of to make it easier for your developers to deal with, right? The point is that this base platform is moving, right? It's developing, it's getting better, right? And it's very hard with this monolithical approach to basically not build a thinking platform, but to build a platform which floats, on this base platform, so that whenever this base platform gets, better, gets improved, that you also kind of receive these improvements, right? And how organizations often solve this is by splitting up these single platform teams into more verticalized platform teams to say, okay, we have application platform, we have integration platform, we have analytics platform, we have a data platform. We all know all these platform teams, right? And the idea is basically just to reduce the cognitive load of these independent platform teams again. That we say, hey, you're responsible for Kubernetes, you're responsible for Kafka, you're responsible for whatever, right? The main problem, beside the cognitive load of these teams itself, is that we, of course, need to align very well the developer experience, so that the customer journey across those platform teams. But even if we would achieve this, we again have an issue which was raised yesterday already by the guys from Red Bull, that we, of course, have a blast radius and resilience issue, right? Because whenever our Kubernetes, for example, goes down, right, we can expect that nothing will work anymore, right? Because all our teams run on this single Kubernetes, right? And of course, we have also solved this blast radius issue by usually then going into more redundant, resilient architecture, say, okay, we have for each product cluster, for each bigger team, whatever it is, right, an independent Kubernetes cluster. We have an independent Kafka and so on and so forth, right? And that sounds like a reasonable solution, because obviously it decreases the blast radius. The problem is, again, and you see we're running in circles, that this has a lot of complexity in managing this stuff, right? And basically, it, again, will make this team explode at some point in time, right? Because if you spin up a new Kubernetes cluster for each team which is coming, then it's obviously a bad idea. And so it seems that we have those two options, right? We have the option of a monolithical platform, right? And we have this option of a distributed platform. The problem with the monolithical platform is that the resilience is really bad, right? The chances are high that it will sink at some point in time and everything stands, right? The distributed platform, on the other hand, is really hard and complex to manage, right? It's obvious that we will oversee things from time to time. It just bloats our cognitive load at some point in time, right? And the thing is that you don't want to be either of them, right? You don't want to operate the ship. You want to be the dockyard of the ship. And what I mean by this is that I think we need to shift our way of thinking, how we think about platforms, right? And what we should actually do is that we don't provide the platform per se, right? We are not the operators of the platform, right? Platform engineering doesn't mean operations. It's totally the opposite, right? There can be platform teams and there can people who take care of base infrastructure. Doesn't need to be the same people, right? Because what we as a platform team are doing is we build a product, right? We build a product for other application teams to make them faster. And we should ship this product, right? We should give this product to the teams, right? And how we usually do this is by giving those teams a developer API. An API where they can define what do I need as a platform. What is my requirement as a team against the platform, right? Where they can basically then go into GitLab, right? I'm a big fan of infrastructure as a code, where they can define here custom resources and, for example, say, hey, you know what? I need a service cluster. I need something where I can run my microservices on, right? And how we usually do this is that we say, okay, that's actually our entry point, right? This is how developers should be able to interact with the platform, right? This is what's the developer API for them. This is how we basically want them to use our things, right? And we have then a GitLab where we can put a custom resource, which basically looks like that, right? We have then a platform team, a control plane cluster where we have Argo, for example, running, where we have Kubernetes running, and we basically have this operator which, for example, listens to our custom resource, for example, triggers a cluster API or something else, and this basically spins then up a Kubernetes cluster in the Argo for our teams, right? So they can define on their own, hey, I need this infrastructure, our control plane cluster will take care that we spin this up, right? And this then, for example, has a configuration to say, okay, there's the workload wrapper, right? We have then somewhere a GitLab running, and basically here we can define additional things like, hey, I want to have this microservice. But even more, we could say, okay, I want to have a Kafka within my platform, right? Then you could spin up with streams, say Kafka in the Kubernetes cluster, or you could basically just spin up an additional Kafka outside, right? Something from a managed platform like Ivan or MSK, right? Or you say, no, I don't want to have an independent Kafka for each team. I want to have a central one, right? And then you basically just give the teams the possibility to create topics. And you do this again by injecting this initially created cluster for them with an operator which picks up this custom resource and which then basically creates the topic, right? So we are nearly done. And what we do is that we basically shift the responsibility from left to right. We shift it from the platform team to the application teams, and we basically do this by just providing the minimal base infrastructure, the minimal base platform, and basically shift the responsibility to the teams to basically own their platform. So let's quickly sum this up. I know I'm shortly over time. Let's quickly sum this up. So we basically went this road from monolithic platforms to fully decentralized platforms, right? With all the things in between, sliced monoliths, distributed platform, and a fully decentralized platform. And I don't say that you should go with the right thing, right? I just say that our experience usually showed that when you really want to scale platform engineering, you basically need to get there, right? And this, of course, always comes with complexity, right? It gives you a lot of advantages, but what you pay for it is complexity. And of course, if you want to start simple, and you should stay as simple as possible, as long as possible, then you need to stay on the left-hand side. So that's basically it, right? I think this whole idea of platform teams make a lot of sense, right? But we shouldn't let platform become our organization bottlenecks in your resilience issue, right? To say what then yours always says, safely and sustainable reduce lead time to thank you. Thanks a lot. I hope this was useful.